So the LeetCode problem we are going to solve now is called palindrome partitioning. We can see that this one is a medium problem, but in my opinion, this should have been a hard problem. We can see that this is a very well-liked problem. Now let's understand that what is being asked us to do. We are given a string S and we need to partition this string S such that every single substring of that particular partition becomes a palindrome, and we need to return all possible palindrome partitionings of S. So it sounds a little bit awkward, but let's try to understand this with an example. First, let's understand that suppose we are given a string S such that the values are A, B, C. So we can see that in this case, if we have to partition string, there are a bunch of different options. We can have a partition that is completely like this, or we can do a partition like A, B, and C, or we can do a partition like A and B, C, something like this one, right? There are a bunch of different ways for us to partition any given string. But the thing is, in this case, we need to find partitions such that every single partition becomes a palindrome. Now we all know that what is the definition of a palindrome. Suppose we are given a value like this ABA. In this case, this ABA is a complete palindrome. Why? Because if we write it from left to right or right to left, in both the cases, the answer is just going to be ABA. So same way, this let's say if this is the input we are given, and if we have to partition it in such a manner that every single substring of that partition becomes a palindrome, we only have one possibility. That possibility is if we partition it by using just individual characters, because an individual character in itself is a palindrome. Because let's say if we only have one value, you can read it from left to right or right to left. In both the cases, we are going to be left with the same value. So this is the only answer we need to return in this case. But let's say that we may have been given some other options. Let's say that our given string S is equal to value such as A, then A and B. Okay. Let's say our given string S is equal to values A and B. So now in this case, we will have two options in order to generate the partition. First partition is going to be quite straightforward, that is taking on individual characters because they are palindrome and their own, and combination of these characters actually form in such a manner that every single character is a palindrome in itself. But we can make one more distinction or one more answer in this case, where if we create a partition of these two values A as one partition and we create another partition of this individual character B, then also this becomes a valid partition of the substring such that every single portion of the partition actually forms a palindrome, because this AA is a palindrome and this B is a palindrome in itself. So this is what the problem statement is actually asking us to solve. Now let's try to understand some logic on how we can actually solve this problem. Well, if we just have to solve it using pen and paper, what is going to be the first logic you are going to apply? Well, the very first logic is that we will start iterating over this given string character by character, comparing every single character with the previous characters that we have been able to find so far, to determine that whether using the combination of previous characters are we able to generate palindrome or not. If we are able to generate a palindrome, we would mark it as one of the partition and then we will keep on moving forward. So let's try to understand the approach I'm suggesting. Let's say over here we start iterating over at this very first element A. Now for this very first element A, the moment we come to this element A, we have two choices. One choice is that A in itself could be a palindrome. So we mark A as a palindrome, and same way there could be another possibility that we may find some value where this A could be potentially part of some future palindrome that we are yet to discover. So let's leave this possibility open for us for the moment. Okay. Now, if we decide to create a partition based on A, then once again, we have the option to move forward with a single A or the next element. So let's say that once again, we decide to move in with a single A and create another partition, which this is the first partition and this is the second partition. Okay. And once again, we move to the another value. And for this next value, we encounter value B. So once again, we create a partition in its own. Now the thing is, when we reach to this B, we realize that now we have reached to the end of our array. So far, all the values we find inside or all the partitions we did for our given string S, all of these values are palindromes, because let's say that in order to determine that whether any particular string is a palindrome or not, we are actually going to create a method that checks that if the given string is a valid palindrome or not. Okay, and this string is quite straightforward. They are the values of itself, so we know that all of these values are correct palindromes. And we are also storing some current array list where we are keeping track of all the current values that we are iterating over one by one. So we realize that this is the correct sequence of the partition that generates a palindrome. So we are going to mark this option inside as part of our answer. After marking this, we are not done yet, because once again I mentioned that there could be some potential ways or some potential other paths that we are able to generate, which could lead us to more palindromes that we are yet to discover. So once again, let's try to apply that same logic in this case. So now once again, we already explored this path. Okay, now what we are going to do is we will do a backtrack operation once again to the very first character to make sure that maybe we did not miss out some palindromes that we could have found. So let's say that we, instead of just creating a single value partition, from this single value we actually decide to do a partition of two values. So creating a partition of two values would give us value a. Once again, we check that if is this a valid palindrome or not, and yes, this is a valid palindrome. So we are good to continue to the next element. For some reason, if we identified that this was not a correct palindrome, let's say for some reason that this value given is x, so then this ax is not a correct palindrome. If this is not a correct palindrome, then it does not make sense for us to continue down this path of partitioning. So then we would choose a different path where after this ax, we would actually include b in our decision making as well. But there is no need to do that. So let's leave it as it is right now. So after leaving it as it is, okay, so we created another partition at this moment AA. The answer is valid, legitimate. So we are keeping it as it is. After keeping this as it is, now we decide to go to make another partition, that is this value b. So once again, we create a single partition of just one value b. This is also a palindrome. And with this b, we reach to the end of our list. So after reaching to the end of our list, we are also going to be marking this sequence that we found as part of the answer as well. Now let's try to clean this up a bit. And now once again, we are yet to explore more possibilities that we haven't found. So we will also try to do this one. Now for the more, initially we took down a possibility where we are only partitioning the string based on just one value. Then we partitioned the string by using values a, and then also it worked out. Now we are going to partition the string based on considering all three values. So let's say that we just create a partition that is a and b. Just because this is definitely not a palindrome, plus we reach to the end of our list. So now we are done with our search with starting all the possibilities from this current value a. Now we are yet to identify more possible palindromes that we are yet to identify. So let's say that in the very first beginning, when we made this partition, now we will continue down this path, but previously we went down this path, that was this answer over here. Now we will try to choose a different path, and in this different path, what we are going to do is, with this a, now we are going to pass the baton on to the next element, and now we will say that, hey, next element, if you want to do or try some partitions, let's check those. So once again, from this a, we can create another partition like ab, but definitely this partition is not a palindrome. So if this is not a palindrome, then it does not make sense for us to continue down this path, and anyways we are running out of elements in this case. But let's say if we had some more elements over here, let's say some more element like say c. So do you think it would make sense for us to create a partition such that a, b and next element to c check like this? No, because we already know that this is not a palindromic substring. So why even bother checking? So then in that case, our logical step would be to include c as part of one of the possibilities as well. But once again, this is also not palindrome. So now we can be done with this. So this is the simplest approach we can take to solve this problem. Now we all know that what we did, we use the backtracking option to basically go through all the possibilities that we can in order to generate or find sufficient answer. Now let's try to understand that what has to be the logic of our backtracking function. This is going to be a simple function that takes the current partition that we are dealing with, and based on the partition from the input string, it is going to have a starting index for the next partition that we are going to check with. And with the starting index of the next value, we should be able to understand that are we at the end of our string or not, and whether we can conclude the current partition to be over or not. On top of it, with every single value, we are going to check for any particular substring that we are generating, that whether that is a palindrome or not. And in order to do that, in order to accomplish all of this, we will actually use recursion. Now for recursion, we know that we have two items that we need. First one is a base case and second one is a recursive function. Base case is quite straightforward, that if I previously mentioned that we are going to have a variable called start to keep track of the next index. That would be the starting point of the next sequence of palindromes. Let's say that we created a subsequence like this, AA as one of the palindrome, then start index would be living over here with value number 2, as that is the logical starting position. So we are going to check that if for the current list we come to a place where the starting index is the length of the given string, then we are going to be marking that current index as part of the answer and returning or coming back through our recursion. So we identified our base case. For the recursive function, we will have to do two things. First thing is that for every single new partition we make, we will have to check that whether this one is a valid palindrome or not. If let's say that is a valid palindrome, then it would make sense for us to call the recursive function once again with the next value in line and creating the current partition as it is. Now I know it sounds confusing, but if you just understand that or try to walk over the solution that I presented, then it would make absolutely beautiful sense to you that what I'm suggesting. And on top of it, for the recursive function, we are also going to be updating the current index value that we are iterating over. Let's say that we iterated over AA, so then we will have a recursive function starting with value number B, and once again we will try to repeat the same process. Combination of all of this should give us the answer, but thing is, this is not just enough. Once we receive a call back, and we will have to check for other possibilities, where first we check for the possibility of A only, then we may have to check for the possibility of AA. So in order to do that, we will have to do a backtrack, and for the backtrack, the simplest thing is to remove the very last element we added inside our current array or current array list, and once again repeat the same operation. So basically combination of backtracking and recursion is the way to move forward in this case. Now let's try to calculate the time and space complexity. Well, time complexity is difficult and tricky to calculate in this case because we don't know that how many number of potential partitions we can make. So at the end of the day, this is simply a decision making algorithm, and in the decision making algorithm, at every given step, let's say that we created a partition like this A. Now we will have to check whether to include this A or not to include this A as part of the partition. So at every given step, we are checking for to whether to make that decision or not to make that decision. So basically we have 2 to the power of n possibilities, where n is the number of characters given, and for every single character we will have to repeat the same operation. So it's going to be n multiplied by 2 to the power of n possibility, and that's why this is a very expensive operation. And if you go through the LeetCode problem, we are only given like up to from 1 to 16 as part of the range of n for the length of the string, because they also realize that they don't want to put much load on the LeetCode servers. So now let's try to quickly see the coding solution for this one. Okay, so the very first thing we are doing is that we are generating a new result array list that is going to store different array list inside it to store our answers. Then we are going to have our backtrack method, where we are passing in first of all the result array list we created. Then we are also passing in the current list we are iterating over, passing in the given string that we are given as the input, and we are passing in the starting value of the next pointer that we should consider for the partitioning. This is the starting pointer that I just mentioned. Okay, now first of all, let's see, in our recursive function we are going to have our base case, where we are first checking that if the starting value is the length of the given string, which means we are actually reached to the end of the string. So we can add the current result we are iterating over inside our result array list, and we can simply do a return call from the iterative stack. And now let's check our recursive case or recursive function. So for that, we are basically iterating over from the starting index till the end of this list, and we are updating the value. And here I mentioned starting and ending pointer. This is just simply so that we can check that the given palindrome or the given sequence of element partition we are iterating over, if that is a substring or not, we can simply make that call. So first thing we are going to check is that if the given current substring, is it a palindrome or not. For that, we have created is palindrome method, where we are doing nothing but we are simply iterating over from both ends, like starting pointer and ending pointer. If at any given moment we identify that there is a mismatch, we simply return false. If that is not the case and we complete the whole iteration, then we can simply return true, saying that this current substring is a palindrome. Okay. After determining that the current set of partition is a palindrome, we are going to add that substring to our current list that we are maintaining. And once again, we are going to recursively make call with the same values, except the next index position that we will have to iterate over, and that is going to be our end plus 1. You can also define this end instead of end to be I as well. I just put in end for it so that it becomes better readable for our is palindrome method. And once we get a result back from our backtrack method, we are simply eliminating the last value we inserted inside our current list, because we still have to explore more possibilities. And this is our backtrack function basically. So now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty fast compared to 98% of all the other solutions, which is exceptionally good. Once again, the solution of this code is presented on our GitHub repository, so you can go and check it out from there. Thank you.